Welcome back to Area Diesel Service. Today we have another exciting collaborative effort with fellow YouTube content creator CNC Equipment. The story, as I understand it, is that inside of this box is a turbocharger off of a John Deere 850J bulldozer, technically an 850JR, which is the military version of the 850J. And this is a machine of the 40,000 pound variety. It's a big boy. It's a modern machine.
The military designates everything with the R on the John Deere equipment. So these are actually called an 850JR. So if you go searching on John Deere's parts, they have a cool online parts catalog anybody can get on. But you gotta type in 850JR. That will pull up the parts listing for this machine here. A lot of this stuff is the same, interchangeable, because some of this stuff you'll look up part numbers for and it will show obsolete just because it's painted green, or it may be that fuel tank's different, or some little nitpicky thing. But 99% of the time it will interchange and fit. So
it sounds like they have a parts dozer that's been sitting around on their facility for quite some time. It sounds like they scored a bulldozer that's in exceptional condition but lacks an engine. This happens to be virtually the same machine that you have probably seen on Dirt Perfect's channel. So his military green John Deere 850 is effectively the same machine as we're looking at here. Modern, electronic engine, electronic turbo, electronic fuel, big machine, yet one that can be moved on a fairly standard type of low boy. Kind of in that sweet spot, big and powerful, but light enough and nimble enough to move it around from job to job. The task at hand is to pull the engine out of the donor that's been sitting on his yard, rebuild it, and install it into this recently acquired low-hour dozer, making a very desirable machine. This is military grade, without emission systems, low hours, and now with a freshly rebuilt engine, and all of this work done by the experts over at CNC Equipment. Clint and Kevin and Uncle Randy and the crew, they've proven their capabilities over there. Couple of specs on your bulldozer. This is a John Deere machine. John Deere 6090 is the engine designation. That's 6 cylinders and 9 liters of displacement. In this application, checking in at 192 horsepower, 550 cubic inch inline 6-cylinder. That is 9 liters for those of you on the logical system. It is a direct-injected, turbocharged, and aftercooled diesel engine running Denso common rail fuel injection. Area Diesel is a Denso service dealer, and it's running BorgWarner turbocharger. Area Diesel is one of about 10 BorgWarner franchise distributors in the U.S. This turbo is supposed to be off of a low-hour engine, but it's been sitting out in the elements for perhaps 10 years. Should be a BorgWarner turbo, should be a variable geometry turbo, which will give us something else to kind of talk about and explore, or at least get a bit of theory and operation. We're gonna bust this dude open and see what we've got. Nailed it. There's 1 hour of labor on the books already just getting the damn thing out of the box. We'll put that on Clint's build. Another quality job from them on the packaging side of things. It's always good to see somebody spend a little time to get these things to us in good condition. BorgWarner S300BV, so 300 size frame turbocharger, and the BV representing and explaining this jazz here. What is this? And what is this? This is effectively the variable geometry component of this turbocharger. So this is an electric actuator. This one happens to be water cooled here, and this actuator plugging into engine controls for both command and speed, 3-wire speed sensor, and the 4-wire controlling the actuator. So the computer will command the actuator to change the position of the turbo, and then the feedback to the computer comes from the speed sensor. It asks for a change, and it monitors the speed to see if the change took place. There's a shaft sticking out of the back of the actuator. So stepper motor, servo actuator, whatever you want to call it, a motor turning that shaft connected to this linkage connected to this lever, and that lever inside of the turbocharger moving the vanes and the mechanism inside the exhaust housing. Why have we added all this jazz, right? And I would say the root cause answer would be your federal government and their regulations regarding engines and emissions and things of that nature. Turbo theory and operation. The exhaust leaving the engine is introduced to the turbocharger from the exhaust manifold through here, and then it's fed around this housing. And as it goes around this housing, that housing becomes tighter and more restrictive, and the gas must speed up, and that gas is what's driving the turbine wheel inside of the turbocharger. A fixed geometry turbo doesn't have this jazz, and the geometry inside of this housing is static and always the same. What they have done in this turbocharger is they've put a mechanism in it with a set of vanes and blades where they can now control the geometry of the turbocharger, and we can vary the restrictiveness inside of the housing so that we can control, or the computer can control, the speed at which the gas must pass through the turbo, but more importantly, the amount of back pressure that's being built up against the turbine wheel here. But why, you ask? Well, that's a great question. The reason that variable geometry was initially designed and installed was because in a boosted application that also uses EGR, right, exhaust gas recirculation.
Exhaust gas is taken directly after the cylinders. Then, the EGR valve regulates the subsequent mixing of the exhaust gas with the intake air. This means that less oxygen reaches the cylinder. Less oxygen means a lower combustion temperature. This way, nitrogen oxide quantities can be reduced by up to 70%. As the higher the temperature, the more harmful nitrogen oxides are produced. A key component of exhaust gas recirculation is the EGR valve. It meters the quantity of exhaust gas that is returned. EGR valves come in various designs and models. Pneumatic or electrical, for petrol or diesel applications, or with connections for cooling.
If you have 30 psi of pressure leaving your turbocharger and living inside of your intake and manifold and cylinder head, and then if you open an EGR valve and the pressure in the exhaust system is only 15 psi, it's impossible to get the exhaust gas to recirculate and flow from an area of 15 psi into one that is of 30 psi. So the initial reason that the engineers developed variable geometry turbos was to restrict the turbine housing, to increase the drive pressure operating on the turbine wheel so that the drive pressure running the turbo exceeded the boost pressure in the manifold, so that when the EGR valve was commanded, flow would exist and you could recirculate that inert exhaust gas back into the engine to effectively dilute the charge air or dilute the fuel mixture, but retain that stoichiometric fuel ratio that we're looking for, or so I'm told. This turbo you'll see here embossed with the John Deere logo. This was OEM supplied component. It was manufactured for John Deere by BorgWarner. And again, AreaDiesel is a BorgWarner franchise distributor. When you buy these types of components from us, you're getting the OEM quality stuff. Most engine manufacturers do not manufacture their own turbocharger. They rely on a BorgWarner or a Holset or a Garrett. Those are the big three that manufacture these OEM turbos for the first fit production line assemblies. This one certainly looks like an original John Deere unit. It is tagged as such, RE535693. Again, BorgWarner S300BV. We refer to it in the aftermarket as a 178-731, or the factory reman variation we refer to as a 478-731. Okay, I'm giving her the old farmer test, right? I'm reaching in, grabbing the shaft. I'm trying to load it radially and see if I can make the wheels contact the housings on both ends, and I cannot. And I'm going to check it axially to see if there's any thrust in it, any excessive thrust play, and there is not. This thing feels like it's in very good condition. Looks like a fantastic candidate for a rebuild. Potentially could have been slapped right back on and ran, but if you know the boys over at CNC Equipment, they're trying to do high quality repairs and they want this thing to be right. They want a satisfied customer. That's enough blabbing. We're going to write it up, transfer it back to the turbo shop, ask them to allow us to capture some updates throughout the process. Once we get this thing scattered, we'll give you a good look at the actual mechanism inside of the turbine housing. We'll show you some of the process, grinding the shaft, honing the bearing housing, balancing the wheels, and we'll bring you along. We are back, and complete cleaning and the actual precision inspection has occurred, and we have confirmed that this turbo is, in fact, in fantastic condition. Likely could have gotten away with just sticking it on the next engine and running with it, but as you know, the boys over at CNC like to do top tier work, and the only way to ensure that this is the highest quality possible is to scatter it and have a look. So that's what we've done. The critical, precise inspection happens on the turbine wheel. So the journals where the bearings ride and the seal area where the piston ring fits is extremely precise, right? And those areas have to be inspected. The diameter here was still completely of factory specification. So we will do a polish on the journal just to make sure that the surface finish is exactly the way we want it, and then rebalance this component to ensure that it is still properly balanced, but don't see anything going on with that. The other super precise, I don't know if we'll be able to pick it up here, but the bore, the inner diameter in here is where the journal bearing sits, and it's also extremely precise. So we're checking it for diameter and concentricity, and it was absolutely perfect on both sides. And then the rest of the inspection is basically one of a visual variety. Excessive pitting. Do we see cracks, particularly in the areas that get the most heat, right? Turbine housing is subject to intense heat, as you might expect. Exhaust coming out of the engine, driving the turbine wheel. It's not only caustic, but it's hot. It's a volatile environment, but this turbine housing cleaned up beautifully. Just a peach, right? All these registers and machine work are still crisp. Surfaces are fantastic. Compressor housing, compressor wheel cleaned up beautifully. You can see factory balancing notches there, but we'll come back and balance that component as well. And then the compressor housing, we talked a little bit briefly before about the dissimilar metal thing. Just a little bit of grit there, but absolutely nothing to be concerned of. The register, fantastic condition. Housing, completely acceptable. The extra components that we referred to earlier, the actual thing that is making this a variable geometry vane cradle sits down in the turbine housing and it gets pinned down. The vane assembly sits on top of it and pins into the holes there. And these are the actual vanes. This is where the geometry is actually varying. Sits on that. And then this is the unison ring. And these blocks all lock in to each of these vanes. And they can be fun to put together. We'll show you trying to get all that aligned, and then the actuator operates on this. So once we get it all back together, we'll show you. These components also sailed right through the inspection process, right? And we don't see any signs of wear. We don't see any bindage, right? That's one of the primary modes of failure. These things will get sticky and stuck, and then the actuator can no longer move them. But again, this one in fantastic condition. We are going to take the rotating assembly back to the machine shop, and we'll try and show you the polish. It's pretty basic. Literally going to chuck it in a drill press and hand polish the journal bearing, and then we'll balance these components. And we do have a new actuator. It was the only thing that was suspect was the actuator. We've got a new one on the shelf. That's about it. We'll come up with the rest of the repair kit, the bearings and seals, and then we'll watch the master slap this thing back together. But before we go, I did want to show you the other style of variable geometry. We talked about the vane style, and these vanes choking off the flow of exhaust turn closer together, like down here. It restricts the flow, and if they open, then the flow becomes less restrictive. The other style, and these parts are junk and they don't fit well, but this is the Holset concept of variable geometry. The exhaust housing, right? Exhaust leaving the engine, introduced here, comes around the turbine housing to drive and operate on the turbine wheel. Their method we call a nozzle, and this nozzle fits down in this, what we call a shroud plate, and the height of this nozzle cage varies. And as it moves in and out, the amount of space that the exhaust gas has to pass through changes, and the velocity of the exhaust gas changes. Maybe we'll get into one of these down the road, achieving the same thing, but much different, right? The other one is running the vanes kind of like a flapper, and this one is changing their height and relationship in that regard. And this one is complete junk. You can see the marks around it signifying all the cracks. And this cage also junk. I don't know if we'll be able to pick it up, but right there above my thumb, little hairline crack right there, hairline crack right there. So those are the types of things when we perform that visual inspection, that's what the guys are looking for. And sometimes that stuff's hard to find, but they've got a keen eye. So
here's our octopus cleaner. It does all the hard work so we don't have to. This is one way we polish the housings here. It runs on a half an hour spinner, then we just flip it, run it again, and parts come out looking fresh.
So not super technical there, but very much part of a high quality repair. We want the surface finish back to an acceptable, and it is. Machine number 412, also one of the many things that I don't know enough about, but this is the wheel balancer it's a West Coast balancing or a Heinz balancer. What you're going to see is we'll put these components up on this arbor, and we'll put a sticky weight, some schmoo on there. We'll set these dials at the appropriate specifications, and we'll spin this thing up, and this light will come on when the heavy spot is up. Then we'll take the sticky weight off of it, and that will reveal the actual high or heavy spot. And then we'll take that component over to a grinder and remove some material, and then come back and check it again. So a lot of back and forth, a lot of hand work, but this thing is extremely precise, and obviously at 80,000 RPMs, a properly balanced component is a critical part of a successful repair. I'll step out of the way and let somebody that actually knows what they're doing run this thing, and we'll get you a little bit of footage of that. Took the sticky weight off and then run the wheel, turn the light back on, and now it reveals the true high spot, right? The true heavy spot.
No, you gotta have right down about the 1 or below.
You want down 1 or below, so the right plane is within, the left plane is not.
But this wheel ain't bad. Some of them you get way worse.
So now he's going to take it over and knock some weight off with a big right there. Bingo, bango. He's got her down below the ground. So on the right side stays within spec. So that was it. That little bitty kiss right there. You can barely even feel it. That's what we took off to put this wheel back in perfect balance. Now we're going to look up the specifications so we can tell the machine the characteristics of the compressor wheel. You can see he's dialing in left and right planes and specifications. And we'll chuck up the compressor wheel and give her a go. So we'll show you the back of it as well. All right, these notches here are factory balancing marks. You see no other balancing other than the factory stuff. That notch as well. So we'll run this up, see what we got, and then you might see it may be perfect, or you might see us just dust the back or hit the hub right there, but we'll show you. Put it up in there, add the sticky weight. A little bit of new smooth on the bearing area. Send it. Adjusting something there. Trying to center up the drive belt. You can see turn on the strobe light. Turning the dial over there to get the strobe on the sticky weight. You can see with the sticky weight on there, the imbalance is reading about a 5. I don't know if you can pick it up on camera, but the strobe is illuminating the sticky weight at the 12 o'clock position. So we're going to shut her down, and then we'll take the weight off. And now with the same calibrations, without anything changing, we'll turn the light back on. And we're going to reveal the true high spot, the true heavy spot. So we're getting a 4 on the left and a 2 on the right. So how do you know that that's the spot that was getting lit up?
Well, usually you'll find a mark where these things are at, then you can tell, which way you gotta.
So you can just look at like these factory balancing marks or whatever.
Yeah, right there.
Okay.
Then I just put that where it needs to go.
Is that a lot of imbalance?
I've seen worse, especially on the bigger stuff.
About 1.5 on the left plane. Going to mark his high spot, confirm that the high spot's marked correctly, and now he's measuring the right plane, and he's nailed it. He's down around a half, so no need to concern himself with the right plane. Coming back on, left plane, just about perfect. So we're at 0, right plane, and a half, which is fantastic. So that concludes the balancing process for the individual components. All right, so you can see attempt number 1, I think, was there where he took off a little bit more, and then he reran it and found a little bit more imbalance and just barely dusted it right there. And that's it. That's the balancing, and on the hub, just kissed it right there, and that's it. That component has been perfectly rebalanced, and we're going to pass it back to the assembly department, and they'll put that thing back together.
We are back in the turbo room, and we're going to assemble the turbo back up. There's a pattern to the bolts, so I call it like a 445. Bolts that will use to bolt down. They're in a certain pattern themselves, so no matter how you spin it, you won't get it right until it's in this pattern. So we have these little spacers. And we have our vanes. And again, there's 4 vanes, there's 4 vanes, and then there's 5. And if everything is smooth, just like that, get the vanes in. And I'll tighten these down real quick, and then I'll show you putting that on. Alright, so there's the unison ring. I kind of got to wiggle and jiggle those blocks that we showed to get them all up in there. So now everything's up in there, bolts bolted down, and then as we wiggle this, you can see the vanes flex. I don't want to go too far because it will actually knock them back out, and I have to start the whole process kind of over again. So everything's smooth. I like it. So from here, I get this arm. It's going to go up through here. And that's pretty much getting the turbine housing ready to accept the cartridge. I'll bolt these down, and then we'll bolt the cartridge up. This is just a sealer.
That is official schmoo.
Yes, but it's a good kind. Hopefully nothing will back out. It's a little stronger than the red stuff.
That is schmoo.
As it gets hot, it'll set. See him flexing a little?
Right there. So he's running that rod that passed through the bracket there, and you can see those vanes moving. You can see the geometry varying right there, baby.
All I'm doing right now is checking the piston ring gaps to make sure I agree. They're good. Just checking that the bearings feel good on the shaft. Okay, so the kit that we use when we repair these type of turbos just happens to come with what we would call like an upgraded thrust bearing. Instead of it being 270, which you would stop here and the thrust collar would slide into, which is this little piece here. This piece can't of course get here because this is a 360 thrust bearing. So the kit that we use when we repair these come with the 360s. The hard parts are just going to be slightly different. I'm going to just tap it around to get it to set correctly. Alright, my setup, the camera current is, I'm not going to be able to show you torquing it down, but I'm just going to move off screen about a foot and I'll be right back. A little bit of oil. The old open palm technique. Alright, so yeah, just torqued it down and we're spinning. Alright, so when this came in and when I tore it apart, I marked the housing. See that there? That was where that lines with our oil inlet feed. We try to do this whenever we tear down R&Rs. That way when we put it back together, hopefully we can get everything back in alignment for the customer. This is where the sensor that was in there, there's this flat spot on the shaft that it reads. So here's actually our oil inlet. So it's slightly off. There we go. This had a fitting when it came in. The fitting will be returned. We just don't normally put the fittings back in when building up. Fresh bolts, fresh lock tabs. So I go on starter pattern and then I just come back and make sure that everything is tightened. Still spinning. I tried to side load it. I'm not feeling the wheel rub, so that's good. Turbine housing assembly now, and then you see right there, it's also where I marked the oil inlet. And these come with these gigantic, goofy clamps. Where I tighten all of them down tight and put it back in alignment with all of our dots. Alright, so at this point we're just, I gotta get the actuator. Because the actuator is not installed right now and this arm is not being held in the correct position, I can actually make the vanes hit the wheels right now, so I don't want to keep doing that. So I'm going to go get the actuator, finish this up, put some plugs in the oil in and drains, and we'll be done here. Alright, so here's our new actuator. I'm going to get it on here mounted up, and then I'm going to install this onto here. 4 nuts bolted down, and then slide this piece up over the gap there, and then another screw that kind of just holds it in place, and there we go. Put the speed sensor back in there just so it's just an open port. Put some oil in here, put a plug here, drain plug in, and there it is. Done. Back together.
We've made it back to the parts counter, and we're going to summarize what we've done with Clint's turbo here. They were deep in the bowels of the engine. They are only interested in doing high quality repairs and selling high quality machines. So this was a while we are there type of affair. The turbo was suspected to be in good condition, and as you saw, it very much was. In fact, it was effectively in mint condition. But again, the request was to ensure that when Clint sells this machine, he's selling something that he can put his name on and stand behind. And we see a fair amount of that here, right? Got it down for an engine overhaul, send us the pump, injectors, turbo, and we want to make sure when we get this project done that we're not going to have any projects for a while. Pretty common to get something that isn't necessarily broken. We tore this thing down, we cleaned it up, we inspected it and found virtually zero wear. We talked about machining some of these components just for sake of creating content. We decided not to, because one, it's illogical and doesn't make any sense. Number two is, and probably more importantly, if we grind this shaft unnecessarily, and then if it has another issue down the road and it needs machine work again, we may have pushed it to a specification where it can't be machined a second time. Okay, the $1 million question, as per usual, what did it cost? This turbo in extremely good condition, and only as of today, we had $750 of labor. That was me struggling to get the box open. That was tear down, clean up, inspection, balancing, straightening, reassembly, and the parts, with exception of this actuator, and we'll talk about that next, the parts were about $90. This situation with Clint and his customer or his project, the actuator that we got was functioning fine, but because we can't really inspect electronics or predict the lifespan, we opted to go with a brand new OEM actuator, 650 doll hairs. So this project, $1,500. Again, not a rebuild as we would generally look at it, right? We didn't do any machine work. We didn't change any tolerances or specifications, but a pretty standard repair nonetheless. Those guys are getting ready to sell a 6-figure bulldozer, and they don't want to scrimp on $1,000 turbos. Please keep in mind, we are not just industrial, we are not just agricultural, we are all things turbocharger. This one happens to be a BorgWarner turbocharger. AreaDiesel is one of 10 or 12 franchise distributors in the US. We are also one of 10 or 12 master distributors of the Garrett turbocharger product line, and the same thing for the Holset turbocharger product line. These are your top 3 global leaders in the turbocharger market, and AreaDiesel is factory direct with all 3 of them, and we are rebuilding and repairing all of their technology up to the current iterations of all of their variable geometries, be it pickup truck, passenger car, agricultural, diesel, industrial, irrigation, power generation, gas pumping, what have you. We're here to help. From lawnmower to locomotive, if you need a turbocharger, please reach out. We would love an opportunity to earn your business. And if you want to see this turbocharger get reinstalled, see if it's going to work for the boys, please go over, check out CNC Equipment, and tell them that we sent you. All right, if you need us, please don't hesitate to reach out. We're here to help, and we pride ourselves in taking good care of our customers and providing a high quality solution, be it a repair or a product from the inventory. So that's it for now. Thanks for watching.